Welcome to Bibliowonder.
Good evening, everyone. Hi, Lucian, and hi to everyone listening. This is the very first episode of Bibliowonder, and from now on, I'll be the one asking the questions, and you'll be the one chasing the answers. I'll admit, I went back and forth for a long time on where to begin.
Hi, Julia. Well, the first question sets the tone for everything that comes after, so I'm glad you took your time. What did you land on?
I decided to open with something that sounds simple and turns out to be bottomless. Something every single person listening is doing right now and cannot stop doing. Time. What is it really? And is it even real? So, Lucian, what is time?
Right now, without thinking about it, you are moving. Not through space, through time. From this moment to the next, steadily, at a rate you can't speed up, slow down, or stop. You've been doing it your whole life. Everyone you've ever loved is doing it beside you. It is the one current none of us can step out of. And here's the strange part. Time is the most familiar thing in your entire experience, and also the thing physics understands least. Ask a physicist what an electron is, and you'll get an answer. Ask what gravity is, what light is, what an atom is. Answers. But ask what time is, and something remarkable happens. The room goes quiet. Because at the deepest level of physics, in the equations that describe how reality actually works, time has a habit of disappearing. Some of the most respected physicists alive will tell you, calmly, that time as you experience it may not be a fundamental part of the universe at all. That the flow you feel right now, this relentless slipping of moment into moment, might be something your mind is doing, not something the universe contains. It sounds impossible. You can feel time passing. You watched it pass this morning. But the closer scientists look, the less they find. Clocks that tick at different speeds, depending on how fast you move. A now that isn't the same for any two people. A past and future that, by the mathematics of relativity, may already exist. Every moment of your life laid out at once, finished, permanent. So the question we're opening with isn't small. It's maybe the largest question hiding inside ordinary life. What is time, really? Does it flow, or do we just experience it that way? Did it have a beginning? And, the strangest possibility of all, does it actually exist? Let's follow it, all the way down, starting with something everyone thinks they understand, until the moment they're asked to explain it.
But before we even get to physics, let's be honest. We all use the word time constantly. Do we actually know what we mean by it?
That's the perfect place to start, Julia, because almost everyone skips it. 1600 years ago, a philosopher named Augustine sat down to write about time, and he left us the truest sentence anyone has ever written about it. "What then is time?" he wrote. "If no one asks me, I know. If I wish to explain it to someone who asks, I do not know." That's the whole problem in 2 lines. You know exactly what time is, until the moment you try to say it. Then it slips through your fingers. So let's start there, with the thing we think we know. Because before we can ask whether time exists, we have to be honest about what we actually mean by the word. And it turns out, we mean at least 3 completely different things, all tangled together. The first is the time of clocks. Measured time. Seconds, hours, calendars, the grid we lay over our lives so we can meet at noon and catch a train at 9. This is time as a number. It feels solid, objective, the same for everyone. Hold on to that feeling, because it's the first thing physics is going to take away from you. The second is the time of change. Things move. Ice melts, candles burn, a child grows tall, a face grows lined. Even if every clock on Earth vanished, you would still know time was passing, because the world keeps becoming different from how it was. Some thinkers argue this is the deepest meaning of time, not a number, but the simple fact that reality refuses to hold still. And the third is the most personal one, the time you feel, the flow, the sense that there is a special moment called now, gliding forward, leaving a fixed past behind it, and moving into an open future. This is the time of memory and anticipation, of regret and hope. It's the time you live inside, and it may be the one that exists only in you. And notice how deeply we've buried time inside language itself. We say time passes, flies, runs out, always moving. We spend it, save it, waste it, as if it were money. We put the past behind us and the future ahead. Every one of these is a metaphor borrowed from space and motion, smuggled in so early we've forgotten it's a metaphor at all. We don't have a single everyday word for time that doesn't secretly picture it as a thing that moves, or a place we travel through. Which should make us a little suspicious. When you can't even describe something without borrowing the language of motion, maybe the motion lives in the describer, not the described. Notice that these three don't have to agree. And the entire strangeness of time comes from the places where they pull apart. Here's a small example to feel it. Think of a memory, a real one from years ago. A room, a voice, a moment. Where is that moment now? It feels gone, doesn't it? Vanished. The past, we say, no longer exists, and the future hasn't happened yet. So on this view, all that's real is this razor-thin sliver of present, this instant, already slipping away as I speak. That picture has a name. Philosophers call it presentism. Only the present moment is real. And it feels obviously, undeniably true. It's how every human being experiences existence. But there's a rival picture. What if the past isn't gone? What if last summer is still there, exactly as real as this moment, just somewhere you can't reach, the way another city is real even when you're not in it? What if the future is already there too, waiting, finished? This view is called eternalism, the block universe, and it sounds like science fiction. Here's what should unsettle you. When we leave philosophy and go to physics, to the most precisely tested theory in the history of science, it is presentism, the obvious one, the one you're living right now, that runs into trouble. And the block universe, the impossible one, that starts to look real. To see why, we have to do something that sounds simple and turns out to break everything. We have to ask whether two clocks, in two different places, can ever truly agree.
So you're saying time isn't the same for everyone? Surely a second is a second wherever you are?
Here's where our everyday intuition takes its first real hit. For most of human history, everyone assumed time was universal. One great cosmic clock, ticking the same everywhere, for everyone. The same second on Earth, on the moon, on a distant star. Isaac Newton built it right into his physics. Time, he wrote, flows equably without relation to anything external. Absolute, unchanging, the stage on which everything else happens. Then, in 1905, a patent clerk named Albert Einstein took that stage and pulled it out from under the world. Einstein's insight began with light. Experiments had shown something bizarre. The speed of light is the same for everyone, no matter how fast they're moving. That sounds harmless. It isn't. Because if the speed of light never changes, then something else has to give. And that something turns out to be time itself. Here's the consequence, and it has been confirmed thousands of times. A moving clock runs slow. Not appears to run slow, runs slow. The faster you move through space, the slower you move through time. Physicists call it time dilation, and it isn't a theory anymore. It's engineering. In 1971, two scientists, Haffel and Keating, did something beautifully simple. They took atomic clocks, the most precise clocks ever built, put them on ordinary commercial airplanes, and flew them around the world. Then they compared those clocks to identical ones left on the ground. The flying clocks disagreed with the ground clocks by billionths of a second, exactly the amount Einstein's equations predicted. The clocks that traveled had literally experienced less time. And you rely on this every single day. The GPS in your phone depends on satellites carrying atomic clocks, orbiting high and fast above you. Up there, time runs at a different rate than it does on the ground, by about 38 millionths of a second every day. Tiny. But light travels fast, and if engineers didn't correct for that difference, GPS would drift by kilometers within a day. Your map would put you in the wrong city. The only reason it doesn't is that we constantly account for the fact that time, up there, flows differently than time down here. So let that land. Time is not universal. There is no master clock. Your clock and my clock, if we move differently, genuinely tick at different rates, and both are right. And it turns personal in a way that still stuns people. Imagine twins. One stays on Earth, the other boards a ship, travels near light speed to a distant star and back. When the traveler returns, she is genuinely younger than the twin who stayed home. Not in appearance, in fact. Fewer days have passed for her. They were born the same instant, and now one is visibly older than the other. This isn't a riddle or a trick. It's the famous twin paradox, and it isn't even really a paradox. It's simply what happens. Two human beings, the same age at birth, can meet again at different ages, having lived through different amounts of time. Time isn't just bending for clocks, it's bending for lives. It gets more intimate than satellites. Gravity does it too. The stronger the gravity, the slower time flows. Which means your head, slightly farther from the Earth's center, is aging very slightly faster than your feet. Over a lifetime, the difference is almost nothing, a few billionths of a second. But it is real, it is measurable, and it means something profound. Even within your own body, there is no single rate of time. Newton's one great cosmic clock is gone, shattered. In its place is something far stranger, a universe where time is personal, local, bendable, a quantity that depends on where you are and how you move, like temperature or speed. But if my clock and your clock can disagree about how much time has passed, then a deeper question opens. And this is where it stops being about clocks and starts being about reality. If we can't agree on how much time has passed, can we even agree on what is happening right now? Is there such a thing as a single, universal moment we're all sharing? The answer, it turns out, is no. And that no may be the most disorienting fact in all of physics.
Wait, if our clocks can disagree about how much time has passed, can we at least agree on what's happening right now? On a single now?
I wish I could say yes. But this is the part that genuinely unsettles me. We use the word now as if it's the most obvious thing in the world. This moment. Right now. Surely whatever else is uncertain, there is a single present instant that the whole universe shares. A cosmic now, stretching across everything at once. Einstein's relativity says there isn't. And this is the part that breaks people's intuition. So let's go slowly. We saw that moving clocks tick at different rates. A deeper consequence follows from that, called the relativity of simultaneity. It means whether two events happen at the same time depends on how you're moving. Two things that are simultaneous for me can happen one after another for you. Not because one of us is wrong, because there is no fact of the matter. At the same time is not a universal truth about the universe. It's a local opinion. For events nearby, you and me in the same room, the disagreement is so tiny, it's meaningless. But scale it up, and it becomes staggering. Philosophers illustrate it with a famous thought experiment, sometimes called the Andromeda paradox. Imagine two people passing each other on a sidewalk. One walking toward the Andromeda galaxy, one walking away from it. Andromeda is 2.5 million light-years away. Because of the relativity of simultaneity, the present moment on Andromeda, the slice of events each person would call now over there, differs between these two strollers by days. For one of them, a fleet might be launching from an Andromeda world right now. For the other, that same launch lies in the future, hasn't been decided yet. And they're standing next to each other. Two people, side by side, with different nows, different slices of reality each calls the present. There is no way to say which is correct, because physics offers no universal present to check against. Sit with what that implies. If your now and my now can contain different events depending only on how we walk down a street, then now is not a special moving spotlight that the universe shines on one moment at a time. Now is just here, for you. The way here is just where you happen to stand. My here isn't more real than your here. They're just different locations. And relativity says the present is the same kind of thing. Your present isn't the universe's present. It's your location in time. Now you might worry this lets everything dissolve into chaos. If we can't agree on what's simultaneous, can we agree on anything? We can. Relativity protects one thing absolutely: cause and effect. No disagreement about now can ever let an effect come before its cause, because nothing, no signal, no influence, travels faster than light. So the order of events that actually touch each other, that cause one another, is something every observer agrees on. What people disagree about is only events too far apart to influence each other at all. Reality stays perfectly consistent. It just refuses to hand us a single universal present. This is the hinge of the whole story, so let me say it plainly. If there is no universal now, then the idea that only the present moment is real falls apart. Because which present? Yours? Mine? The stroller walking toward Andromeda? They can't all be the one real moment, and physics gives us no way to crown a winner. And once the special universal now is gone, something has to take its place. If the present isn't a privileged slice of reality gliding forward, then what is reality? What does the universe look like when you stop assuming there's a single moving moment? The answer that relativity points to is the strangest idea in this entire episode. It says that past, present, and future may all be equally real. That the universe is not a story unfolding, but a finished thing, existing all at once. Every moment of your life, already there. They call it the block universe, and Einstein himself believed it.
So if there's no shared now, what does that do to the past and the future? Are they gone? Or still out there somewhere?
Brace yourself a little because this is the big one. Here is the picture relativity leaves us with. Imagine the entire history of the universe, every event that has ever happened or ever will, laid out at once, like a vast landscape. Not a movie playing frame by frame, but the whole reel existing all together. Every frame, past and future, equally real, equally there. Physicists call it the block universe. Space and time fused into a single four-dimensional block, space-time, and within it, every moment simply is. In this picture, your birth is not gone. It's still there, at its location in the block, as real as this moment. Your 10th birthday is there. This sentence is there. And this is the vertiginous part. The day of your death is there too, already existing, at its own fixed coordinate. Nothing is coming. Nothing is passing. It all simply exists, the way every city on a map exists at once, even though you can only stand in one at a time. The flow of time, in this view, is not a feature of the universe. It's a feature of how you move through the block. A traveler who can only experience one location at a time, mistaking their own journey for the landscape moving. It helps to hold one image. Think of a strip of film, a movie reel. When you watch the film, Frames flow past one at a time, and it feels like motion, like now. But the reel itself? Every frame already exists, all at once, sitting in the canister. Frame 1 and frame 10,000 are equally there. Nothing is being created as it plays. The playing is just a light moving across frames that were always present. The block universe says reality is the real, not the screening, and the motion is in the projector, in you, not in the film. This isn't a fringe idea. It follows naturally from relativity, and many physicists take it as the most honest reading of the equations. And Einstein himself seems to have believed it, and found comfort in it. When his closest friend Michel Besso died, Einstein wrote to Besso's family. "People who live as we do," he wrote, "know that the distinction between past, present, and future is only a stubbornly persistent illusion." Besso had not vanished. He was simply elsewhere in the block, at his own moment, which exists as surely as ours. Think about what that offers, and what it takes away. It offers a strange immortality. No moment you've lived is ever truly lost. Every laugh, every face, every ordinary afternoon, permanent, fixed forever at its place in space-time. But it takes away something we hold dear. If the future already exists, finished, then is anything open? Are your choices real, or are they already sitting there in the block, waiting for you to arrive and feel like you're making them? That question has no settled answer, and honest physicists admit it. The block universe is a serious, well-supported reading of our best physics. But it is not the only one, and here we reach a genuine fault line in human knowledge. Because there's a problem the block universe can't easily explain, and you feel it every second. If every moment is equally real, if nothing truly flows, then why does it so overwhelmingly feel like time moves? Why do you remember the past and not the future? Why does coffee cool but never spontaneously reheat? Why does the egg break but never unbreak? The universe, at its deepest level, may not flow, but our experience screams that it does. And the bridge between those two, the reason a timeless universe feels so relentlessly like a river, turns out to come from the most unlikely place. Not from time at all. From heat and disorder, and a single law that points always in one direction.
But Lucian, if nothing really flows, then why does it feel so overwhelmingly like it does? Why can't I unbreak an egg?
And the answer comes from the least romantic place imaginable. Heat. Drop a glass and it shatters. You have never in your entire life seen the reverse. Shards leaping off the floor, assembling into a glass, hopping back into your hand. Stir milk into coffee and it blends. It never unstirs. Smoke spreads from a fire. It never gathers itself back into the flame. The world is full of one-way streets. This is the arrow of time. The deep, lived sense that the past and future are different, that time points one way. And here is the astonishing thing. That arrow does not come from time itself. It comes from a single principle called the second law of thermodynamics, the law of entropy. Entropy is, roughly, a measure of disorder, of how many ways the pieces of a system could be arranged. And the second law says, in any closed system, entropy almost always increases. Order crumbles into disorder. The neat becomes the messy. Why? Pure counting. There are very few ways for a glass to be whole, and almost infinitely many ways for it to be a scatter of shards. So when things change, they overwhelmingly drift toward the more numerous, messier states. Not because a law forbids the reverse, but because the reverse is so astronomically unlikely, it never happens. The egg breaks because broken has trillions more arrangements than whole. And this gradient from order to disorder, is what gives time its direction. The past is simply the direction in which entropy was lower. The future is the direction in which it's higher. That's it. The arrow of time is the arrow of entropy. Now here's where it touches you directly. Why do you remember the past, but not the future? Most people assume it's because the past already happened. But physicists give a deeper answer. You remember the past because the past had lower entropy. A memory is a record, a bit of order, an imprint left in your brain, a photograph, a footprint. Records can only form in the direction of increasing entropy. You can have a memory of yesterday because yesterday was more ordered than today. You cannot have a memory of tomorrow because tomorrow is more disordered, and a record of it can't form yet. Your entire sense of a fixed past and an open future, the very texture of being alive in time, rides on this one statistical law. So the flow you feel may be exactly this. You are a creature made of order, embedded in a universe slowly dissolving into disorder, and you experience that slide as the passage of time. The river isn't the universe moving, it's entropy climbing, and you, riding the current, calling it now. And you are, physically, an entropy machine. Every thought you think, every move you make, every heartbeat takes in order and pumps out disorder. You eat low-entropy food and radiate waste heat, leaving the universe a little messier than you found it. Life itself is a temporary local eddy of order, holding back the tide for a while, and paying for it by increasing the disorder all around it. You are, quite literally, one of the ways the universe has found to climb the entropy hill a little faster. The strange price of being alive is helping time move. This is one of the most beautiful results in physics. The block universe says nothing truly flows, and entropy explains why it feels like everything does. The two fit together. Reality is timeless, experience has an arrow, and the arrow is made of heat and probability. But the moment you accept that the arrow comes from entropy, a haunting new question opens up beneath it. And physicists consider it one of the deepest unsolved problems in all of science. If entropy only increases, then it must have started incredibly low. Someone, somehow, wound the universe up into a state of extraordinary order at the very beginning. Why? Why was the past so perfectly tidy? The answer takes us all the way back to the first instant of everything.
So the arrow comes from entropy. But where does entropy's direction come from? Is it built into the laws themselves?
Here's the riddle that quietly keeps physicists up at night. Here is a fact that sounds like a riddle and is completely true. The fundamental laws of physics do not know which way time goes. Write down the equations that govern particles, Newton's laws, the rules of electromagnetism, even quantum mechanics, and you find something uncanny. They work exactly the same forwards and backwards. If you filmed two particles colliding and played the film in reverse, the reversed film would also obey every law of physics perfectly. At the microscopic level, there is no arrow. The past and future are mirror images. Time has no preferred direction at all. Let that sink in, because it sharpens our whole mystery. The deep laws are time-symmetric. They don't care about past or future. And yet the world we live in is wildly, obviously one-directional. Glasses break, people age, smoke spreads. Where does the arrow come from, if the laws underneath don't have one? We just saw the answer: entropy, statistics, the overwhelming likelihood of disorder. But that answer has a catch, and it's a big one. Entropy increases toward the future because it was lower in the past. Roll the logic backward. Yesterday's entropy was lower than today's. The day before, lower still. Keep going, back through history, back before life, before Earth, before the stars, and you arrive at a universe of breathtakingly low entropy. Extraordinary order. The beginning of everything, 14 billion years ago, was wound up tighter, more ordered than anything since. And nobody fully knows why. This is called the past hypothesis, and it's one of the great open wounds in physics. The second law isn't really a law about the future, it's a consequence of the past. The only reason entropy can rise is that it started so impossibly low. But low entropy states are rare, astronomically rare. The universe could have begun in any of countless high-entropy, disordered configurations, and instead, it began in one of the vanishingly few orderly ones. Why? We don't know. Some physicians think the answer lies in the physics of the Big Bang we haven't cracked yet. Some think it points to something before the Big Bang. Some think it may never be explained. But notice what this means for our question about time. The arrow of time, the entire difference between past and future, the reason you age, the reason you remember, the reason anything happens at all, does not come from time being fundamentally directional. It comes from the universe having started in a special, ordered state. The flow of time is, in a sense, the universe spending down the order it was born with. How strange is that orderly beginning? Picture shuffling a deck of cards and having it come out in perfect order, every suit in sequence, and then doing it again and again, perfectly, every single time. You'd know instantly something was going on. Flawless order doesn't happen by chance. The universe's low-entropy birth is that, dialed up beyond imagination. An orderliness so wildly improbable that some physicists have called it the single most puzzling fact in all of cosmology. Everything we call the flow of time leans on it, and we still have no agreed explanation for why the dice came up that way. So we've now pulled time apart into pieces. Clock time bends and stretches. The universal now is gone. Past and future may both be real in a timeless block. And the flow we feel is entropy, riding on a mysteriously orderly beginning. At every level, time keeps turning out to be something other than what we thought. Which leads to the boldest question of all, the one a growing number of serious physicists are now asking out loud. If time bends, if now is local, if the arrow is just statistics, maybe time isn't a fundamental ingredient of the universe at all. Maybe, when you go deep enough, down to where space and time themselves are born, time simply isn't there. And there's an equation, one of the most important in modern physics, where exactly that happens. Time vanishes from it completely.
You hinted there's an actual equation where time just vanishes. That sounds impossible. What is it?
It is impossible to get used to, honestly, even for the people who study it. In the 1960s, two physicists, John Wheeler and Bryce DeWitt, were trying to do the hardest thing in science. Combine Einstein's relativity, which governs the very large, with quantum mechanics, which governs the very small. A theory of everything would have to marry the two. They wrote down an equation meant to describe the quantum state of the entire universe, and when they finished, something was missing. Time. The variable for time simply wasn't there. It had dropped out of the equation entirely. This is the Wheeler-DeWitt equation, and physicists have been arguing about it ever since. Their best attempt to describe the universe at the deepest level produced a portrait of reality with no time in it at all. A frozen, timeless equation, describing a cosmos that does not evolve, does not flow, does not tick. They call it the problem of time, and it is exactly as profound as it sounds. Now this might be a mistake, a sign the equation is incomplete. Many physicists think so. But a growing number take it at face value and draw a radical conclusion, that time is not fundamental, that at the bedrock of reality, there is no such thing as time, and that what we call time emerges, appears, only at larger scales, the way temperature emerges from the jiggling of countless atoms. No single atom has a temperature. Temperature is what trillions of them feel like together. Time, in this view, might be the same. Not a thing that exists at the bottom, but a pattern that appears when enough of the timeless bottom is gathered together. The physicist Carlo Rovelli has spent his career on this idea, and he puts it bluntly. The world is not made of things moving through time. It is made of events, happenings, relationships, processes. And time, is just the name we give to the way these events are ordered relative to each other. There is no master clock underneath. There are only events and their relations, and out of that web, the appearance of time arises. Picture it like this. Imagine the universe as a vast piece of music. We tend to think the music plays in time, note after note, carried along by some external clock. Ravelli's suggestion is the reverse. There is no external clock. There is only the music, the notes, and their relationships to one another. And time is simply what we call the experience of the notes being related. Remove the music, and there's no empty time left over, ticking in silence. The relations are all there is. It sounds abstract, but remember everything that brought us here. Clocks that disagree. A now that's only local. An arrow made of statistics. A beginning we can't explain. A fundamental equation with no time in it. Piece by piece, time has been dissolving in our hands. And this is where the pieces point. How could time appear out of timelessness at all? Here's one way physicists think about it. Imagine a perfectly still, frozen description of the whole universe. No clock, no flow, just a vast web of correlations. This matches that, this is linked to that. Now suppose you are a part of that web, a subsystem, like a brain, that records correlations, that builds up traces of the rest of the world inside itself. From the inside, reading those traces in order, you would experience a before and an after. You would feel time, even though the universe as a whole is just sitting there, timeless. Time, on this view, isn't a property of the cosmos. It's a property of the relationship between a part of it and the rest, the view from inside. But if time is not a fundamental thing, if the universe is really just a web of events with no clock underneath, then we owe ourselves one honest, careful look at what that actually means. Because the world is events, not things, is not just physics. It's a different way of seeing everything around you, including yourself. And it's far more beautiful than it first sounds.
The world is events, not things. Help me actually picture that. What does it mean for, say, a rock? Or for me?
Gladly. And fair warning, it changes how you see everything, including yourself. Look at a stone, and you see a thing. Solid, lasting, the same today as yesterday. But that's a trick of our time scale. Watch the stone for 10 million years, and you'd see it behave like a wave. Forming, weathering, dissolving, gone. The only reason it looks like a permanent thing is that we live and die so fast compared to it. Now turn it around. Look at a kiss, a storm, a sound, a thought. We call these events brief happenings. But Ravelli's point is that everything is like this. There are no permanent things. There are only events of different lengths. A stone is just a very long, very slow event. You are a slightly faster one. A flash of lightning is a fast one. The whole universe is not a collection of objects sitting in time. It's a collection of happenings, of processes, woven together. And this reframes what you are. You feel like a thing, a fixed self, persisting through time, the same person who woke up this morning. But on this view, you are not a thing at all. You are a process, a flowing, an ongoing happening, like a flame or a wave or a melody. A wave is not a chunk of water. It's a pattern moving through water. You are not a chunk of matter. The atoms in you are replaced constantly. You are a pattern, a song the universe is briefly singing. This is, quietly, one of the oldest human intuitions, now meeting modern physics. 25 centuries ago, a Greek thinker said you cannot step in the same river twice, because the water is always new. The Buddhist traditions of Asia built an entire understanding of reality on the same insight. That permanence is the illusion, and that everything, including the self, is impermanent process. What physics is now whispering through the Wheeler-DeWitt equation, contemplatives have been saying for millennia. The world is verbs, not nouns. And here's why this matters for time. If reality is made of events and their relations, this happened, then that, this caused that, this remembers that, then you don't need a separate thing called time underneath it all. Time isn't the container the events sit in. Time is just the ordering of the events themselves. It's the relations, read in sequence. Take away the happenings, and there's nothing left over to call time. The web of events is the whole story. Time is its shape, not its stage. You can almost feel the shift if you try it for a moment. Look around wherever you are, and instead of seeing objects, a table, a wall, a hand, try to see processes. The table slowly sagging and aging, the wall weathering atom by atom, the hand warm and pulsing and quietly replacing its own cells. Nothing is truly still. Everything is mid-happening, just at speeds too slow or too fast for you to notice. The solidity of things is an illusion of timescale. Underneath, it is all motion, all event, a universe that is not a noun, but one enormous, ongoing verb. So perhaps the deepest answer to what is time is this. Time is not something that exists. It's something that happens. It's not a river the universe floats in. It's the unfolding of the universe itself, seen from the inside. But I keep saying, seen from the inside. And that points at the last piece we haven't touched, and maybe the most personal one. Because everything we've discussed has been physics, out there, in the universe. Yet the most vivid time you'll ever know isn't in the equations. It's the time inside your own head, the felt flow, the dragging hours and the vanished years. And that time, it turns out, is something your brain builds. Which raises a strange and beautiful question. How much of time lives in the cosmos, and how much lives only in you?
Okay, that's the universe's time. But what about the time I feel, in here? Why does an hour sometimes vanish and sometimes crawl?
This might be my favorite part, Julia, because it's the most personal. You have no sense organ for time. You have eyes for light, ears for sound, skin for touch. But nowhere in your body is there an organ that detects time. And yet the feeling of time passing is one of the most vivid things you ever experience. So where does it come from? The answer, your brain builds it. Time, as you feel it, is a construction, assembled moment by moment inside your head. Start with the now. It feels instantaneous, a single knife edge present. It isn't. Your brain actually stitches together about 2 to 3 seconds of incoming experience and presents it to you as a single, smooth now. Psychologists call it the specious present. The felt present is not a point, it's a small window, a little gathered span the brain hands you as if it were one instant. The now you live in was assembled a fraction of a second ago, from signals that arrived at slightly different times, edited into seamless presence. You are always, very slightly, living in the past. And the brain's clock is wildly unreliable, which you already know from experience. Time flies when you're absorbed and crawls when you're bored. An hour of joy vanishes. An hour of waiting is endless. In real danger, a car crash, a fall, many people report time slowing to a crawl, the world turning syrupy. Researchers think this happens because fear makes the brain record memory far more densely. More detail laid down per second feels, in memory, like more time. The clock didn't change. The recording did. And here is the one that touches everyone. Why does time seem to speed up as you get older? Why was a childhood summer endless, and now whole years slip past like weeks? There are a few explanations, and they may all be true at once. One is proportional. At 5 years old, a year is a fifth of your whole life. Vast. At 50, a year is 1/50th, a sliver. Each year is a smaller fraction of the life you've lived, so each feels shorter. Another is about novelty. When everything is new, childhood, first love, a new city, the brain lays down rich, dense memories, and that density reads later as length. As life becomes routine, fewer new memories form, and the years compress. This is why a week of travel can feel longer in memory than 3 months of routine. Time, in memory, is measured not in hours, but in how much you truly noticed. The brain's editing can even be caught in the act. Glance suddenly at a clock with a ticking second hand, and that first second often seems to last too long. The hand appears frozen for a beat before it moves. It's called the stopped clock illusion. What's happening is that during the rapid flick of your eyes, your brain briefly went blind, then covered the gap by backdating the first thing it saw, stretching your sense of that moment to paper over the blackout. You are, constantly and invisibly, editing your own timeline, and you never notice the cuts. The seamless flow you trust completely is a film your brain is splicing together in real time. There's something quietly profound in that. It means the felt length of your life isn't fixed. It's not about how many years you get. It's about how awake you are inside them. Novelty, attention, presence. These literally stretch your experience of time. The person who keeps noticing, keeps learning, keeps being surprised, lives a longer life from the inside, even if the clock says otherwise. So now we have 2 times. The universe's time, bending, local, maybe not even fundamental. And your time, constructed, elastic, painted fresh by your brain each moment. And the gap between them is the whole mystery. The cosmos may not flow at all, but you flow, constantly, because flowing is what your mind does with reality. Which leaves the questions we've been circling toward from the start. If time is this strange, does it even have a beginning? Was there a first moment? And could we ever move through it differently? Could we travel in time? The answers are not what science fiction taught you. One of them is already real, and it's happening to you right now.
Let's go to the edges then. Did time have a beginning? Was there a before the Big Bang?
The honest answer doesn't just answer the question, it bends it. If time can bend and stretch, a natural question follows. Did it ever begin? Was there a first moment? And if so, what came before it? For most of history, before the beginning felt like an obvious question. But modern cosmology gives a strange and subtle answer. According to the Big Bang theory, the universe began about 14 billion years ago, not as an explosion in space, but as the beginning of space and time themselves. Space-time, the whole block, started there. Which means the question, what came before the Big Bang, may be malformed, like asking what's north of the North Pole. There's no before, because before is a direction in time, and time itself begins at that edge. The physicist Stephen Hawking loved this idea. He proposed with James Hartle what's called the no-boundary proposal, a model in which the universe has no sharp first instant, no edge where time switches on like a light. Instead, as you approach the beginning, time gradually becomes less and less time-like, smoothly rounding off, the way the lines of longitude on a globe converge and smooth into a single point at the pole. There's no wall, no first tick with nothing before it. Time just gently ceases to be time. Asking what came before, Hawking said, is like standing at the South Pole and asking which way is further south. The question simply runs out. And if time can have an edge like that, a place where it fades into something that isn't quite time, then it really starts to look less like the eternal stage we imagined, and more like a feature of this universe. Something that came into being. Something perhaps that could fade out again. Some cosmologists speculate that in the far, far future, as the universe expands and cools and entropy reaches its maximum, a cold, dark, featureless state, time itself may, in any meaningful sense, end. Not with a bang. With the simple fact that when nothing changes, when there are no more events, there is nothing left for time to be. Not everyone accepts the no-boundary picture, and this is live science, not settled fact. Some physicists explore models where our Big Bang was not the absolute beginning, where it emerged from a previous universe that collapsed, or budded off from a larger cosmos, or is one beat in an endless cycle. In those pictures, time might stretch back before our beginning after all. We genuinely don't know which is right. But notice that every one of these serious models treats time as something with a history, something that switched on, or emerged, or cycles. Never the eternal, fixed backdrop Newton imagined. However the beginning works, time is part of the story, not the stage the story is told on. But there's the other direction everyone wants to ask about. Not the beginning or end of time, travel through it. Can we move through time the way we move through space? And here's the answer that surprises people. Forward time travel is real. It is established, tested, undeniable physics. We saw it already. Time dilation. Move fast enough, and time slows for you relative to everyone else. An astronaut on the International Space Station, orbiting for months, returns to Earth a tiny fraction of a second younger than they would have been. They have literally traveled into Earth's future. Push it to the extreme. Fly near the speed of light for what feels to you like a year, and you could return to find centuries have passed on Earth. You'd have skipped ahead. That's not fiction. That's the same equations that run your GPS, taken to their limit. Forward, then, is open. But backward, returning to the past, is where physics turns fierce, and where the deepest paradoxes of time finally bare their teeth.
And the question everyone's been waiting for. Can we travel through time?
Yes and no. And the two halves couldn't be more different. Going backward in time is not obviously forbidden by physics, and that's exactly what makes it so troubling. Einstein's own equations of general relativity permit, on paper, strange configurations of space-time, where the path of time loops back on itself. Physicists call them closed time-like curves, routes through space-time that return you to your own past. The great logician Kurt Gödel, Einstein's friend, found one such solution in the 1940s and reportedly worried his friend with it. The mathematics allows it. But the moment you allow travel to the past, you walk straight into paradox. The famous one, the grandfather paradox. Travel back, prevent your grandparents from meeting, and you're never born, so you never travel back to prevent them. So you are born, so you do. The logic eats itself. A loop with no consistent story. Physicists take this seriously, and they've proposed a few ways out. One is Stephen Hawking's chronology protection conjecture, his half-serious, half-deadly earnest proposal that the laws of physics conspire to forbid time travel to the past, keeping the universe safe for historians. Whenever you try to build a time machine, something, quantum effects, infinite energy demands, always intervenes to shut it down. The universe, on this view, simply does not permit the paradox to occur. Another is stranger and more elegant, the self-consistency principle, associated with the physicist Igor Novikov. It says backward time travel might be possible, but only consistent loops are allowed to happen. You could go to the past, but you could never change it, because whatever you do there was always already part of history. Try to shoot your grandfather and the gun jams. You trip, you miss. Not by magic, but because the only events that can occur are the ones that keep the story consistent. In this picture, the future and past are locked together in one unbreakable, self-agreeing whole, which, notice, is exactly the block universe again. Everything already there, already consistent, no contradictions possible, because nothing is ever truly changed. And maybe that's the quiet thread running through this entire story. Every road we've walked, the bending clocks, the local now, the timeless equation, the paradoxes of travel, keeps leading back to the same unsettling, beautiful picture. A universe where past and future are not open and flowing, but laid out, whole, complete. Where the deepest truth is not a river rushing forward, but a vast, still landscape. And the rushing is only us, moving through it. And the practical barriers are staggering. The space-time loops that general relativity permits would demand conditions we may never reach, exotic matter with negative energy, or wormholes somehow held open against their own collapse, or energies beyond anything that exists. No one has ever observed a closed, time-like curve. No experiment has sent even a single particle into its own past. So as far as we can tell, the past is sealed. You can race into the future as fast as your speed allows, but the door behind you, the one marked yesterday, appears to be locked from the other side. And given the paradoxes waiting in there, perhaps that's a mercy. We've taken time apart almost completely now. We've seen it stretch, lose its universal now, dissolve into entropy, vanish from the fundamental equations, and turn out to be partly built by the brain. So we have to return finally to the question we started with, and try to actually answer it. After all of this, what is time? Does it exist, or doesn't it? And if the universe doesn't really flow, then what exactly is this life you're living right now? This moment that feels so unmistakably like it's passing.
All right. After all of it, the bending clocks, the block, the vanishing equation, give it to me straight, Lucian. What is time? And does it exist?
Let me gather all of it and try to answer as honestly as I can. So let's gather everything and answer it honestly. What is time? The most truthful answer science can give right now is layered, because time turned out to be not one thing but several, stacked on top of each other. At the surface, time is what clocks measure, and we learned that even this bends. There is no universal clock. Time runs faster on a mountain than at sea, slower on a fast-moving ship. One layer down, time is the order of events, the sequence of happenings, the before and after woven into the fabric of space-time. Deeper still, time is the arrow of entropy, the one-way slide from order to disorder that gives past and future their difference and powers your every memory. And at the very bottom, in our best attempts at the fundamental laws, time may not appear at all. It may be emergent, a pattern that arises from a timeless reality, the way a wave arises from still water. So does time exist? Here's the honest answer. As a fundamental ingredient of the universe, a cosmic river flowing for everyone, almost certainly not. The flow appears to be something we bring to reality, not something we find in it. The universe may be a vast, timeless block of events, and the present may be no more special, cosmically, than here is special in space. And yet, the flow is the realest thing you will ever know. You cannot step out of it. You were born into it. You love inside it. You will leave it. Whatever the equations say, you are a creature of time, a being made of memory and anticipation, of entropy climbing, of moments that feel, undeniably, like they pass. To say time isn't real is true in the physics and false in the only life you'll ever live. So maybe the resolution is this. Time is not a thing the universe has. Time is something you are. You are not an object sitting in a river of time. You are the flowing. You are the universe, briefly, experiencing itself as a sequence, noticing, remembering, becoming. The river isn't out there. The river is you. And we should be honest about the humility here. No one has closed this question. There are brilliant physicists who believe time is fundamental and real, that the flow is telling us something true our equations simply haven't captured yet. There are others just as certain it's an illusion. The block universe, the emergent time picture, the arrow built from entropy. These are our best current readings, not final verdicts. Time may be the very place where our physics is still most incomplete. But that isn't a failure. It's an invitation. The thing you swim in every second of your life remains, genuinely, one of the great unsolved mysteries, and you get to live right inside the question. And if that's true, it changes what this moment is worth. If the block universe is right, then this moment, right now, you, here, listening, is not being swept away into nothing. It is becoming permanent, fixed forever at its place in space-time, indestructible, never to be unmade. Every ordinary moment you've ever lived is still there, still real, still yours. Nothing that has ever happened to you is truly lost. The physics doesn't make time smaller. It makes this moment larger. Because if the present is all you ever really have, and if, in the deepest sense, it never actually leaves, then the only thing that was ever asked of you was to be here for it, to notice it, to be awake inside the one moment that is always, somehow, now. And that may be the final secret time has been keeping. We spend our lives afraid that time is running out. But perhaps time was never a thing that could run out. Perhaps it was only ever the name we gave to being alive, and the question was never how much of it we have, but how much of it we are actually here for.
Before we close the very first one, Lucian, if people carry just one thing out of all this, what should it be?
So here you are, at the end of our first conversation, held, like everything else, in a moment that physics says may never truly pass. We went looking for time and found that it bends, that it has no shared now, that it may not exist at the bottom of things at all. We found a universe that may not flow, and a self that cannot stop flowing. And maybe that's the gift hidden in all of it. You spend so much of life waiting for the weekend, the next stage, the someday. But if the deepest physics is right, there is no river carrying you towards some better moment downstream. There is only this, the moment you're in. Permanent, complete, already enough. The clocks will keep ticking. They were never measuring what mattered anyway. So before you drift off, just notice, gently, that you are here. In this one moment, the only one that is ever truly now. And ask yourself, as you go, if no moment is ever really lost, which ones will you choose to actually be awake for?
I don't think I'll look at a clock the same way again.
That was what I hoped. And what a question to begin with, Julia. If the first one runs this deep, I can't wait for the rest. Until next time.
Take care, everyone.